Okay, well, I have 10 o'clock. So, hello everybody. Welcome to our webinar from the Safe Food Alliance, Challenges in International Trade. My name is Wiley Hall. I'm the Director of Research Chemistry. With me today, my co-presenters, Thomas Jones and John Kimball. I'll let them both give themselves a brief introduction when it's their turn to speak. But just as we kind of gather attendees, we'll just kind of take a slow walk through some of these introductory slides.
Welcome.
So to those who are not familiar with our company, both all of us, Tom, John, and I all work for Safe Food Alliance. DFA of California is our parent company, and then we have a sister company, Safe Food Certifications. And then just kind of brief slide describing what everybody does. For those that are certainly worked in dried fruit or tree nuts in the Central Valley of California, you probably know DFA of California. We do a commodity inspection, Red Seal program, which comes along with that, and then we administer a couple export trading companies and do arbitration between our members. Safe Food Alliance, which again is the branch of the company that's bringing you this webinar, is really where all of our food safety activities sit. So that's laboratory testing, research, training and consulting, which is where John lives, and then GMP and DFA member audits. And then, like I mentioned, we have kept separate from the company to avoid any conflicts, Safe Food Certification, where we have our third-party certification audits, including Costco supplier audits. Right. So let me go ahead and switch screens, and we'll get started with our material for the day. All right, so trade and international trade is kind of a broad subject. So, there's a couple, kind of sub presentations we're going to give today on a variety of topics, and we'll start off with, where I live, pesticide analysis. So, just kind of a brief primer on MRLs and the international market. So, basic information that I think everybody should know about what MRLs are, where they come from, some other important terms. And then we'll go through some of the kind of primary export markets from California and the US, and go over how these regulations differ from location to location. So really, before we dive into MRLs, we should take a step back, and what are pesticide residues? Well, I mean, it's, just like it sounds. The pesticide residue is the, what's left over, the residual amount of a pesticide. So you take, any crop protection product, apply it in the field or wherever you're growing your commodity, and whatever's left over after harvesting, processing, etc., is your pesticide residue. Things that are important to note is that, along with the kind of, classic things that people think of when they think of pesticides, insecticides, fungicides, etc., it also includes some that you might not think of, fumigants and sometimes sanitizers. It can also include reaction or degradation products like metabolites and any impurities or non-active ingredients that are present in the pesticide product. So these levels are regulated. In the United States, we call them food tolerances. The rest of the world calls them MRLs, maximum residue limits, or sometimes you hear residue levels depending on who you're talking to. And this is done for a variety of reasons that we'll kind of go through. So the MRL is the maximum legal limit of a pesticide residue on a food, right? Things that are, again, it's important to make it clear that MRL is specific for the combination of a chemical, an active ingredient, and the commodity, either the food or the crop group, if you're talking broadly, oranges or citrus. But the thing is that, the MRL for, let's say, glyphosate on apples is going to be different, or can be different, than the MRL for glyphosate on grapes is going to be different than the MRL for acetamiprid on grapes. And if you don't have an MRL for that specific combination, then any detectable amount is illegal, with some caveats to that we'll get through when we go through the markets. In the U.S., it's the EPA that sets MRLs, and as you kind of go across the world, it tends to be, if not the environmental regulator, then maybe food and drug type or agricultural ministries that share this duty. They are reviewed periodically and can either be updated or sometimes canceled. And then sometimes you have other localities that can set further requirements on top of that. Like in California, the Department of Pesticide Registration has issued some additional buffer zones for the use of 1,3-D that aren't on the national registration. All right, so this is just kind of a very general mock-up of how MRLs are set. It begins, like all these things, with animal studies. And the goal here is to determine what is the largest amount of this chemical that that we can dose an animal with and have no observable adverse effect, right? So that gives us the no observable adverse effect level, NOAEL. Right, from there, we're going to put in 100 times reduction, a safety margin, because, as we scale this up to the size of a human, we don't always react to things the same way another animal would. And from there, they can calculate the acceptable daily intake, which is the chronic exposure limit, and the acute reference dose, which is the acute exposure limit. From there, develop a proposed label, go out in the field, apply it, again, harvest, do all the normal processing that you might do, and see what's left over. Apply some statistical analysis, and what pops out at the end is an MRL. So the idea here is that if you follow the label, right, you apply the right amount, you rate the right time, you do everything that you're supposed to do, then your residue should be below the MRL. And if it's not, then it's not necessarily that there's a food safety issue. It's not that it's immediately dangerous, but it does mean that somewhere in the process, the growing process, application process, something went wrong. Someone did something they're not supposed to, and that's where the penalties come in. So it's really more of a trade agreement than a safety limit. So I borrowed this from a European crop protection agency group, but I think it's a nice kind of graphical representation of this. So again, as we increase in the risk to human health, down here at the bottom we have the MRL, and then there should be some space between that before we get to the real toxicological limits, the again reference dose and the daily intake level. And then again, theoretically at least, there should be another good amount of space, that 100 times reduction, before we get to the actual level where we start to observe adverse effects. Again, this is everything working as it should. So now, of course, this is a kind of idealized mock-up. In reality, you get that toxicological data, do the residue study, and it goes into this kind of black box where we've got politics and trade and public perception and maybe dietary differences. And, really that's, there we get our MRL. And as you look at different jurisdictions, as you go across the world, it really tends to come down to the idea of hazard versus risk, or what's the worst that could happen? What's the hazard versus, well, how risky is it? What is likely to happen? You can describe risk as being hazard with exposure. Also, as you look at it, it also tends to come down to the approach of the European Union compared to the approach of the United States. Although this is for chemicals, with biological hazards, it kind of flips, and the US takes a more hazard approach, and the EU is more risk-based. So if we're talking about hazard versus risk, if we have, say, a shark, someone that's working on a hazard basis might say, well, that's a high hazard. The person that's then taking a risk-based approach can say, well, but we're going to put the people in one of those shark cages, so it's really very low risk, to which the hazard-based person might reply with this. So, and onward it goes. Not to say one is better than the other, but those are kind of the two philosophical bases of the approach. Right. A few other things I think are important to know are residue definitions. So sometimes, measuring a chemical is not as simple as just measuring that specific chemical. Here you can see for the United States, the residue definition, which tells you what you need to measure to determine what the residue of glyphosate is. And, there's a lot here, a lot of different forms of glyphosate, but at the end, you're measuring only glyphosate, as opposed to the Australian definition, which is a lot shorter, but you see that it's not just glyphosate that you need to measure, but two of the metabolites, N-acetyl glyphosate and AMPA, that you sum to make up the total residue for glyphosate. So that's something that's important to be aware of, and if you're doing laboratory testing, to make sure that they're reporting the right residue definition. Another thing, this one kind of lurks in the background, but is important, in a regulation sense, is import tolerances. So this is where you have a situation where a given country does not want a pesticide to be used in that country. But again, the small amounts of residue that might come in on imported food, that they're fine with. They're worried about the effects for workers or people that are nearby or the environment. But, the food residues aren't, that's not a concern for them. So you can set what's called an import tolerance. This can be a little easier to get. You don't need to have all the environmental fate, data, things like that. But it can also be politically sensitive. If you imagine the nation of Wiley, if I go to my farmers, my growers, and say, your competitors can use this product, but you can't, you can see how it gets a little dicey. All right, so just to wrap things up, just go through some MRLs across different export markets and talk about how they change from place to place. So we'll start with the European Union, who really, along with the United States, tends to be, kind of one of the big dogs in pesticide regulation. Again, as you can see by this graph on the left, this is for grape and wine MRLs, but the EU tends to be, quite a bit more restrictive when it comes to chemical hazards than the United States. One thing that is nice is that they do have this default limit. So if you don't have a specific MRL, then it defaults to a limit of 10 parts per billion. But 10 parts per billion is a pretty small amount, and really, instruments are improving. That tends to be about the detection limit. So it's really just maybe a half step better than just saying any detectable amount. Lots of testing, lots of publicity for violations. You can also have retailers that set secondary standards. So maybe they'll say, to sell things in my store, everything needs to be, our MRL limit is 1/3 of what the EU says. And then finally, there are these cutoff criteria, which can cause a sudden loss of MRLs. So the way this regulation works is that if something is found to be inherently dangerous, and you can see in the middle here several criteria for what they consider to be inherently dangerous, then the regulation requires that that pesticide be cut off from the marketplace. So the registration is revoked, and then a lot of times the MRL goes back to the default along with that. If this does happen, the change becomes effective in 20 days. So this can happen very quickly. Although if you can show that the product was applied back when that residue was legal, you get a 6-month grace period, which may be fine for a fresh commodity, but maybe tree nuts, grain, something that's been sitting in a silo for a while, wine, if you've got that 5-year-old Cabernet, again, when everything was applied when it was legal, but now it's been cut off, what do you do? A few other markets, Japan, another fairly restrictive, locale, although, it doesn't show up quite as much as it did with the EU, looking again at grape and wine MRLs. But they do have extensive testing and pretty serious penalties for violation. You can see here, first violation, just for the violator, a 30% test and hold. On the second violation, everything coming in for that industry-wide is held until it tests and comes back as legal. South Korea is another one to keep a look at. They've just recently, in the last couple of years, have been implementing their own new positive list system. They do still have a default MRL of 10 part per billion, and they've been working really hard. But the MRL list, isn't quite as complete as we might like it to be. And a lot of the temporary MRLs that they had set while they were making this change are going away. So, it's kind of a dynamic situation that if you're sending things to South Korea, you really need to keep on top of. Canada, for a long time, you can see that there's a lot of MRLs that are the same as the United States. We used to do, we've always done a lot of joint reviews with the US EPA, but that seems to be going away, or at least the word is that they're kind of moving away from that joint work with the EPA. They also had a fairly generous default MRL of now 100 parts per billion, so 10 times higher than EU and Japan. But the word is that that also might be going away soon. But there is compared to the other locales, maybe more limited testing and penalties. Similar situation for China. You can see a lot of commodity, a lot of U.S. MRLs are not don't have a counterpart in China. Very limited lists, but it's something they've been working on. Also, historically, very limited testing, but again, that's also starting to grow. I think we recently had, kind of the first couple violations of U.S. product going into China. And then no defaults and no system for import tolerances. So, really, kind of a sleeping lion there. Hasn't been a problem yet, but could very easily turn into one. And then finally, kind of a surprise, locale showing up on this list, but Mexico has, become a market to pay attention to recently. You started within the last year or so, they've started rejecting import of products, and these are pesticide products, not commodity, but products that contain glyphosate, with the goal of completely phasing out glyphosate by 2024, and more to come. They've issued a list of 136 different pesticides that are registered in the U.S. that are on their list to, at the very least, take a critical look at and decide if it might go the way of glyphosate. All this is based on a hazard precautionary principle. So really, as the registrations for these products go away, what effect this will have on MRLs is, unknown. Again, you can see from this graph here that usually in a lot of cases, Mexico just used the US MRL for a lot of products and commodities. So how that will change as they kind of go down this hazard-based road is unsure. Right. So to wrap things up, if you have any questions, I'm sorry, I should have said earlier, please go ahead and type any questions into the question and answer area. While one of us is talking, the other two will keep an eye on that. Some of the questions will hold to the end. Some of them, if you need clarification or something, then we'll go ahead and break into the talk. Keep it kind of loose and semi-formal here. But so the last slide on pesticides. It's complicated. There's a lot of different regulations, a lot of different governments involved, and it's always changing. So it's really critical that you keep informed and you keep updating your information. But, the information is publicly available. John, I think, will talk about, Brant Christie's website database, which is, a good source of information. You're always welcome to reach out to myself or Tom or anyone else at the Safe Food Alliance team. So with that, I'll put my personal information up there if you need to contact us about any questions about pesticides. And if there don't see any things showing up in Q&A yet, so I think we'll just move along with to Tom's part of the presentation. And if something comes to you later, again, feel free to put it in there, put it in the chat, and we'll respond to it down the line.
Thank you, Wiley. Well, as Wiley mentioned to you, my name is Thomas Jones, and I am the Senior Director of Analytical Services here at Safe Food Alliance. I've been with the company a number of years and have seen a lot of growth and diversity in our services that we offer, lots of changes. It's amazing how, as the world becomes more global and more interconnected, we see, increasing challenges, as Wiley was mentioning, in the pesticides. that trade is very beneficial, but it comes with its share of challenges that we have to navigate. And one of the ones I want to talk about today is from the standpoint of products coming in or being returned to the United States through the FDA detention sample process. So with that, we do have a process in the United States that is called the automatic detention of imports under Section 801 of the Federal Food, Drug, and Cosmetics Act, and it's termed detention without physical examination. Basically, this means that the product comes in, the FDA themselves don't necessarily need to inspect or test it, but that product is put on a hold, and that recommendation is typically based on the finding of one violative shipment if there's reason to believe that the same situation will exist in the future for lots coming from a specific shipper, grower, geographic area, or country. And it specifically relates to some sort of a food safety hazard or sign of adulteration. So a microbiological or chemical hazard, could be pesticides, could be a mycotoxin issue. We even see products put on detention for insect infestation or some of these other defects. Again, this FDA import alert list is typically ever-changing, but it is based on previous findings from FDA. Now, FDA is doing their own testing periodically of products coming into the United States, and if they find an issue, then they put these loads on their import alert list or put these suppliers on their import alert list. It can apply to a specific firm or to an entire country. So if we go on to the import alert list, and the web link there on the lower left-hand part of the slide shows you where that is located, you can go through and see listings of specific firms or entire countries. It just depends on how extensive those violations have been that they've seen. This is an example, 99.05 detention without physical examination on a raw agricultural commodity. In this case, it's a Chilean supplier, and it's the pesticide diclofop in lemons. That's a very specific supplier that has been noted to have these issues. On the other hand, there's another alert I show here, 99.15, countrywide detention without physical examination of processed foods for persimmon, which is a pesticide in raisins, and it applies to all raisins from Turkey. So depending on who the supplier is and the nature of the defect, it may just refer to a specific company, or it may refer to everything sourced from that country. So what happens if there is an import alert list or detention without physical examination citing for your supplier? You have some options. The importer can test those loads and submit that evidence to FDA. Now, the FDA typically spells out what type of sampling and testing protocols have to be followed, and then that must be submitted by a deadline that is listed on a notice of FDA action. And FDA will typically issue a notice if a load has been held and put in detention without physical examination to that consignee or the importer, telling them that this is happening. If the FDA accepts the report that's done on that load, it can be cleared for entry into the United States. So, for example, if we have this detention of Turkish raisins, plenty of Turkish raisins do get imported into the United States, and they don't necessarily have persimmon on them. So if you go through the process of testing them, showing that they are free of this pesticide, then they will be released from that hold. However, if there is an issue found, those rejected products have to either be reworked, destroyed, or exported. And we have seen product come in that was, for example, had insect damage or insect infestation. They went through, they basically treated for the insect infestation through fumigation. They went through and basically resorted the product, removed the items that had insect damage, basically reworked the product, and then were able to prove that that product was now free of adulteration, and they were able to have that load cleared. Some things to think about. What happens if this happens to you? And this does happen on a fair number of occasions. One thing I will also point out too is that we can see detentions on loads, for example, that have been shipped from the United States, have gone through some sort of testing or evaluation overseas, and then been returned. And so for a prime example of that would be tree nuts going into the European Union being tested for aflatoxin. We have different standards. So the limits for aflatoxin for tree nuts are lower in the EU than they are, for example, in the United States. So sometimes those products will exceed the EU limit, be sent back to the United States. But if those loads are low enough to basically meet the US standard of 20 parts per billion, then they can go through a testing process and be cleared. So this happens with re-imported products as well. So let's say you've had that happen, or you're importing produce from another country and you get into these import detentions. The first thing you want to do is really read that detention notice very carefully. Find out who your compliance officer basically is, your FDA compliance officer. That's essentially your caseworker or the person that you need to connect with. Reach out to that individual immediately and find out everything that you can from them as far as what you need to do. Find out what the charge is, and typically it has a charge or basically a defect that is listed. And you then have to respond by that date to that report. Of course, you want to develop a plan right away. You don't want to sit on these things. These are not your typical samples. So you want to call your laboratory. Of course, I put Safe Food Alliance in there because those are the laboratories that we represent. You want to call your laboratory right away. In our office, it's Pamela Cooper, who's our quality manager, who deals with these packages all the time. We have to do a very specific sampling and testing. And the testing and sampling is very rigorous. It has to be done to the standards that the FDA typically would use in their own laboratories and their own testing procedures, which basically meets a legal standard. So this is usually a fairly expensive process, kind of extensive. You do have to go through extra quality steps that you wouldn't in a routine testing sample. You may have to do some reconditioning, and you may have to request an extension. The main thing is you don't want to ignore this until the last minute. You want to immediately reach out to FDA once you get the detention notice and start working with them. They're usually reasonably willing to work with an importer on doing those extensions if they show that they are in fact working on trying to solve the problem. Once you have the necessary data, you've either done your reconditioning and or your testing, you're able to then submit that testimony to FDA, and hopefully the load is cleared. I notice over here on the right-hand side here, we have a notice about an article that we wrote. Pam Cooper and myself put together that kind of summarizes what you have to go through in the FDA detention process. That is available on our website, and we'll make sure that you're able to check that out too. This is actually a figure that came from that publication showing what the leading causes for FDA detention are when we went through and actually examined the cases that were listed. And 45% of the issues that we dealt with in our laboratory were aflatoxin. Again, as I mentioned, often these loads will go overseas. EU is one place they go. Sometimes they go into Japan. They will have an exceedance and be shipped back or re-imported. So we have to go through that process. Coming in second at 19% of the cases we've dealt with are pesticides, again, often on product that has been sourced from overseas. 16% on pathogens, and another 16% on quality or filth. So that might involve insect infestation or other issues. Sometimes we do get claims on mislabeling or organoleptics or rancidity. And one of the mislabeling things that we've dealt with are sometimes products that are imported, for example, sulfite-treated dried fruits. If there is an exceedance of the documentation accompanying that load as far as the levels of SO2, for example, we had apricots, I think, coming in from Turkey, and the levels were still 2,500, 3,000 parts per million. It said 2,000 was the target on the spec sheet, and the FDA rejected that load. Some of the load was retested and the numbers had dropped, but for those parts of the load that were still in excess of that label, they were rejected, even though the importer was providing testimony that, hey, those numbers will drop as we process this product. The point was it had been mislabeled, and that is also a violation of the Food and Drug Code. So that's basically the short story of FDA import detentions. Definitely will be happy to answer questions. I noticed we had a few things pop into the chat room there. And certainly we're available to answer questions throughout the course of the webinar. I guess at this point, I can basically end sharing, and I will introduce John Kimball, who's our next speaker.
Hey there, everyone. Thanks, Tom. So I'm John Kimball, as he said. I'm the Senior Food Safety Manager here at Safe Food Alliance, and I work more on the training and consulting side of things. And I suppose I ought to share my screen so you can see my PowerPoint here. Um, so we deal with customers in terms of conducting audits, in terms of helping them get ready for audits, a lot of different types of food safety training. One of the things we specialize in is kind of customizing training to your needs. So whether it's the 2-day HACCP you need, or whether you just need a couple hours of HACCP training for your team, and everything's going virtual now. So we do offer both virtual and on-site, but I think Tom, Wiley, we've gotten pretty accustomed to this virtual format now.
Yes.
Yeah, and so it's pretty comfortable at this point. So a lot of companies are opting for that now because of the restrictions on travel, or just trying to limit people on site at their facility. So I do want to point out to all of you attending today, there is a chat box. There is also a Q&A function. So please don't feel like you have to sit here and just listen. We do want to try to make this as interactive as we can. If you have questions, and I know you do, I'm hoping you'll jump in and let us know what those questions are, so that, I'm sure there's things that we didn't think of as we put the PowerPoint together that maybe you want to know about. So we're happy to answer those questions. So I'll be talking a little bit about food fraud in this portion here, and then talk a little bit about some of the import restrictions coming into the US with FDA through the FSVP Rule, the Food Safety Modernization Act, and then I'll also talk about some resources, some of which you guys have already touched on. So, so with this thing we call food fraud, there's been a lot of different interesting cases over the years of things that have occurred. This is one that has been commonly known. This was back in 2013 now. Kind of hard to believe it was that long ago, but horse meat being funneled into the marketplace, and we were seeing meats that were supposed to be from other animals that contained horse meat, which was definitely a mislabeling, illegal situation. And so definitely problematic in terms of supply chain. This one here, all too common, right, is things being recalled due to undeclared allergens that are not on the ingredient list. So sometimes food fraud is actually a food safety issue as well, where somebody could actually get sick. So it does kind of fall into both categories. All right, so sometimes food fraud is a risk in terms of the quality of the product and the legality of it, right? So it doesn't meet legal requirements in terms of identity, but also sometimes it can be a very significant food safety risk. So on the quality side, we're talking about things like dilution with a cheaper item. So commonly known, maybe you've heard of this, honey being diluted with, sugar syrup or some sort of similar item, maybe corn syrup, or olive oil being diluted out with a cheaper vegetable oil. So that, being sold as extra virgin, but it's not extra virgin olive oil any longer. Another common one actually is things being sold as organic when they're not, because you can charge a premium for organic products, as many of us know. Another one too is terroir or regional claims. In fact, I worked in the wine industry for 10 years, and at one point there was an issue with Pinot Noir supplies. After the movie Sideways came out, everybody wanted to drink Pinot, and we were short on supply, and so there were some products being diluted out with other red wines and sold as Pinot, but they didn't meet the legal standards. But let's talk a little bit, just touch on food safety risk. So when we use low quality or contaminated ingredients, raw materials in products, that becomes a food safety risk, right? There's a reason we pick out the moldy and insect damaged items on the raw side. They often will bear a pathogen risk or mycotoxins, things like this. If we have poor hygiene in the facility, and we do see that sometimes, we'll see a company that falsifies their audit, their certification, right? So a GFSI audit, for instance, they'll either falsify that audit or pay off the auditor, or some companies will have multiple locations and they'll audit their best plant, but what they're shipping you comes from another facility. Substitution, this is a common one too, and people have gotten into legal situations where they've been liable for deaths because of substituting peanut for almond or similar things like that. So, and then another one is peanut and cumin. So there was cumin, and spices are a high dollar item, an expensive item. And so they are commonly found to have additional items in them. And in this case, somebody put peanut shell or peanut products into the cumin before grinding it. And that became a very serious food safety risk. So Tom, I don't know if you saw, Wiley, but we have an MRL question. So maybe when we're at a reasonable stopping point, we can address that. But I'll kind of keep going with this section really quick. So have any of you ever done a web search for something and then you see ads for Amazon trying to sell it to you? Well, I did a web search for food fraud, and Amazon truly does have everything, because I got an ad for food fraud at Amazon. I thought that was pretty hilarious. So I said, you know what, I'm not letting that opportunity go by. I took a screenshot of it. So I just kind of thought that was a little bit funny. But we'll go ahead and jump into a little bit about the FSVP rule. It's the Foreign Supplier Verification Programs rule. So it's part of FDA's Food Safety Modernization Act, or as we call it, FSMA. So the FSVP rule has a set of requirements in terms of food safety programs that importers here in the US have to meet. And so it does require somebody in the US to be a contact or a responsible party for any imported goods. So any of you that are importing, I'm sure have dealt with this. We need to have a documented supplier approval process. So we're purchasing from approved suppliers. There is an allowance for temporary approval of suppliers, but you've got to have some measures in place to make sure you're getting what you expect. We have to have written procedures for verification activities on these things as well. So what are we doing to verify what we're receiving, right? And qualified and trained individuals. So we've got certain activities that are called out in the regulation. Each of those activities has to have an assigned person that is qualified, that has proper training and knowledge to do that. And that's a theme throughout the FSMA regulations, is qualified individuals. Every rule has some measure of requirement for qualified individuals. We also have to go through and do a risk assessment by product. So for all of our products, and you may have seen some of these FSVP warning letters coming out from FDA the last few months. And so people that are importing are maybe not doing this risk assessment or not executing verification on some items. And so they're getting warning letters on this. So we've got to do our verification. We've got to have corrective actions in place when something goes wrong. And that verification can be lab testing and sampling. It can be inspection, verifying a C of A, and often it is going to be an on-site audit of our supplier that we get and have on file as well. Then there's some requirements of importer identification at entry and record keeping. And the FSVP rule uniquely is largely record review, not site visits. So FDA is going to call you up, they're going to email you, and they're going to ask for certain records. They're not typically going to be visiting all of the importers. Unless there's a reason to. So stated reasons for the rule, just very briefly, they want foreign suppliers to produce food that is being produced through FSMA compliant processes and procedures. So if I buy something on the shelf here in the US, it should be produced to the same level of standards, regardless of whether it's imported or domestic, right? Ultimately, all food that's regulated by FDA is required to not be adulterated or misbranded. Those are the two things in the FD&C Act, right? Everything kind of falls under those two in my mind. So allergen labeling would be misbranded, right? The horse meat situation would be misbranded. And then adulterated would be something that's harmful, right? So ultimately, the same level of public health protection from domestic or imported foods is what we're shooting for. Now, another thing to note, and I thought this was important to bring up too, is FDA's laboratory accreditation rule that they're working on. It's not finalized yet. We do have a draft, right, Tom? There's a draft out. And so if you want to take a look at what they have spelled out in the draft and what they're looking at enforcing, there would be some specific tests on imported goods that would be required to use these labs that are accredited or approved through this program. All right, certain commodity testing requirements as well. And the unique thing with this rule is if this product has to be tested under the rule and it has to go to one of these labs are going to be reporting the results directly to FDA. All right, so now again, this is a draft, so you have time to make comments on it, but interesting, and maybe a little bit of logic there, right? That if it's a critical food safety concern, maybe that makes sense to be reported directly to FDA, but that was kind of raising some eyebrows, I think, when we saw that requirement. So, Tom, Wiley, feel free to jump in if you have any comments. I see another question. Is
Yeah,
there
but it
any
seems like you're about
database
to
for
get to
food
it.
fraud in dried fruit, nuts, and seeds? I'll probably address that, Ute, in the next section, and then after that, maybe we can answer if you didn't get what you needed there. And then I have some chat in here. What's in the chat? Let me just check. All right, will all notes be available later? Started late. I don't know if we're going to be providing anything. Maybe one of the administrators. Oh, Tom, you said we will. Okay, great.
Yeah, I think we're supposed to be providing like the actual presentation if they want to
The
see
recording.
it.
Okay, the recording.
Available,
Okay.
and certainly the other resources that went with it, the slides and everything.
Sorry, I didn't see the responses in there at first.
Yeah,
All
that
right.
FDA, comment on the FDA approval of the labs is kind of interesting because it can include not only like import samples, but if FDA does an inspection of a facility and they decide to take environmental samples or product samples, they can request that you send them to one of these approved laboratories, and then that data is shared with them. So it's a big change.
And I have to wonder how that's going to play out because, of course, we're talking about food sold in the U.S., right? But they have regulatory oversight of facilities that are shipping things to the U.S., right? And so anybody overseas shipping over to us may fall under that as well, right? Where they may need to submit samples from their facility, their products through that process.
Right.
So, all right, well, just a couple of slides here on some resources, and then we'll jump into the next topic. So FDA does have on their website, if you search for this term, the firm/supplier evaluation resources for FSVP rules, or you could just search for supplier evaluation and you may find it. But it's a kind of a central hub they created that has warning letters, import alerts, recalls, as you can see, industry resources, import refusals, right? So there's some very useful information related to import into the US. But of course, different regulatory bodies look at what each other are doing, right? And so regardless of where you're importing or exporting to, if you get on one of these lists, or if one of your suppliers gets on one of these lists or experiences, a situation like this with FDA where you've gotten a warning letter, that's something that other countries will pick up as well. So it'll be something you'll need to resolve. In Europe, we've got the RSSF, right? So there are food and feed safety alerts. So you can find information here. You can search this website. You can sign up, I believe, for email notifications and things like that. So that is kind of a central hub of information that's really useful for things they found in Europe. And I've noticed that, again, Tom and Wiley, feel free to comment, but I've noticed that sometimes we'll see a little bit different perspective in Europe because there may be importing commodities from areas that we don't import much from. And so it's useful when we're considering shipping from overseas.
Yes. Oh, absolutely.
Yeah. And then FARP, right? So they're recognized as an authority in terms of allergens, and they have this great resource on their website to help you find requirements related to different allergens in different countries. So they've got this interactive map that you can click on, and then below it, they've got this chart that I'm only showing you a portion of here. They've got a lot of different countries in there, and they're indicating what the recognized allergens are in those countries that you need to be concerned with as the kind of like our big 8 in the US, right? Other countries have different allergens that are identified as of the most concern. And then just briefly, 3 more paid services to be aware of. So Horizon Scan is a service that a lot of companies are starting to use now that is very proactive. You can set up notifications where it will notify you each day with the latest, or even in real time with the latest on recalls, on information about different commodities, countries, things like that. They've got a really great kind of dashboard interface that you can use. And then the food fraud database that Discernus has is also a great resource. They've been putting information into that for years as well. And then finally, as you said, Tom, Bryant Christie, is also a great resource in terms of information on regulatory requirements in different countries. So,
And
that's
John,
my,
we should point out that if you're in the U.S. at least, their pesticide database is free access.
Mhm.
oh, great.
And is a really it's the first place I go to when I have pesticide questions. Really detailed database.
Yeah, it's really a great resource. I mean, you punch in the commodity, you put in the chemical, and then you put in the export market, and it shows you all the information you need to know. So it's really very useful.
Yeah, so the question that we had earlier in Q&A about resources for food fraud information, these in particular, the previous two definitely have a lot of food fraud. I don't know if Bryant Christie has much on food fraud,
I don't think so.
but Discernus and Horizon Scan definitely do. So anyhow, but yeah, so jump in with any questions that you guys have on the chat, on the Q&A. I'm going to stop sharing my screen here and I'll let you guys jump back in again. I know you've got another portion to present, Tom.
Sure.
And just to reply vocally to the question we had on MRLs earlier, we had a question asking the reasoning for the differences from location to location, and kind of if it's based on science or politics and other things. And really it is again meant to be based on science, or what is the amount you would expect based on the approved uses of a chemical. But that's I don't think I could plausibly tell you that it's that there's no politics or trade policy involved. The other question was, or the other part of the question was where the defaults come from. And it's if you think about maybe listening to the radio as you kind of get closer and closer to the actual station, if you're old enough to remember using a dial to set the radio, there's a point where the static kind of becomes actual people talking or singing, and you can tell the difference. But if you go back a way, it's kind of hard to say where the static ends and the actual signal begins. So kind of setting these defaults is a nice way to say, instead of having each lab maybe, what's their, individual policy, or this is where we draw the line. It's nice to say, well, 10 part per billion. If you measure it as being that much, then, it counts. If it's below that, then it doesn't count. So that's kind of my take on the logic behind the different default residue limits.
Yeah, and I think to add on to that, Wiley, as you mentioned earlier, it's difficult to say that the politics don't get involved. Of course, when you're dealing with different nations, they have different constituents, elect different folks to be in charge, and they have different concerns.
Yeah.
The United States has always had a relatively easy time of it in the sense that we know where a lot of our food is grown. We are a large agricultural exporting country and producing country, but many parts of the world are not that fortunate. And so a lot of their food is coming from overseas. And even in the United States, when we see imported foods, there's a higher level of consumer anxiety about the safety of those products. So certainly people voice their concerns to their elected officials and they act accordingly. So definitely there is a component of that there.
Yeah, I mean, and it might not be fair to say that one motivation, it's not quite as clear as saying one motivation is scientifically based and the other is politics. I guess I would say that the politics inform how you interpret the scientific data. If I say that our best scientific guess, estimate, let's say, not guess, but our best scientific data tells us that if 1 million people consume this amount of a chemical, then three more of them will get cancer than if we had 1 million people that didn't consume that amount of chemical.
Right.
That's the scientific data, but do you consider that significant enough risk to lower that limit, or do you say, well, people are going to get cancer, three more out of 1 million isn't that much? That's where the politics come in, or maybe there's bound to be a better term for that than politics, but where the different interpretation and maybe cultural differences come in.
I agree. All right, well, let's keep rolling here. A little bit about laboratory approvals for export. I found that fantastic picture above of a container ship moseying through the ocean. I thought it was pretty cool. All right, so when we're talking about selecting a laboratory to do export, there's some things that we need to think about. For example, to start with, your laboratory may be determined for you by the buyer. Many buyers, even overseas, have laboratories that they prefer to work with or have been approved. And so they may have an approved list of laboratories that they want you to send those samples to. But you may have a choice of approved labs. Ideally, that's typically, more often than not, that is the case. They usually have more than one laboratory that they've approved. And you need to evaluate them as you would with any supplier. And some of the questions you need to ask when you talk to that laboratory is, first and foremost, do they have the testing I need? You know, typically this is chemical and/or microbiological testing. Are there specific methods that are dictated by the buyer? Are they accepting AOAC methods, or do they have a specific ISO method? I know I've seen testing methods from some markets like Japan that are unique to that country. So you may need to really find out from the laboratory if they're set up to do the specific test you need. Also, the specialized testing you might need for certain export markets. Pesticides, as Wiley mentioned, are a major thing that we discuss in international trade, an area of major difference in terms of limits, MRLs, and perceptions. So you want to make sure that they have the testing to see the residues that you need to have detected. Also, any other chemicals of concern for export. So if there's acrylamide or mineral oil, saturated hydrocarbons, the MOSH/MOA concern that EU has, you want to make sure that they have that ability to do that testing. There may be other things they require of you too, validation or challenge studies. Maybe the buyer needs you to make sure that the method has been fully validated to their standards, which may be different from the laboratory standards, or maybe they need you to do a challenge study to show that that product will not support the growth of a pathogen, and or any additional research you may need to do before you're able to actually ship that product overseas. So make sure that they are doing the testing you need, and talk to them. That's the number one thing. Talk to the lab. They should be freely available and willing to talk to the clients about what their capabilities are. First and foremost, too, is the laboratory accredited. Really, the global standard for laboratory accreditation is this ISO 17025. Pretty much all laboratories involved in the international trade testing world are accredited to this standard, as are we. This is a very documented process, documenting all the procedures for all these operations. It is rigorously audited to these procedures. The methods themselves have to be properly validated and followed for the testing. And one thing you want to look at, it's not just the accreditation of the overall lab to that quality standard, but does the scope of the accreditation meet your needs? In other words, the scope of the accreditation basically says what specific tests have been audited to the ISO standard. And typically in a laboratory, they may have a number of tests that they do infrequently or not for most clients. And so maybe those are not part of the ISO scope of accreditation. They may not have all of the additional record-keeping requirements applied to them, and they're not listed on that scope. So you want to make sure if it's an ISO accredited test that you need, that it is on that scope, that list of tests that they do. There may also be other certifications or accreditations that are required as well. And these are some export certification examples that I know we have in our own laboratory. For example, USDA has a laboratory accreditation approval program. This is often requested by foreign governments for specific commodities to address specific issues. For example, aflatoxin in almonds and pistachios bound for the EU. We have a laboratory accreditation program and basically an agreement between the European Union and the United States government and the commodity boards here to basically have this laboratory program in place where we know that the sampling and testing has been done to standards approved of by the EU. And we're able to actually, as a result of this, have a reduced rate of surveillance testing when those products are shipped over to Europe. So the confidence level is sufficient in the EU, in the testing methods and the protocols in place, that they don't have to spend as many of their resources testing the product. And there's a relatively higher rate of success than of handlers here or shippers here being able to send things overseas and not have them rejected. Another example of an accreditation or approval we are an official laboratory on the official labs list of the Japanese Ministry of Health, Labor, and Welfare. And again, Japan is a major export market for a lot of our clients. This is a critical approval we have because this means the certificates of analysis are accepted by what they call quarantine officers or the import officials in the ports in Japan. So if we have the testing done here in our laboratory as an official lab, we're able to actually get those passed or approved by the Japanese quarantine officials. So again, something that can help you with your importing process. I'll dive quickly into quality measures and then we'll go back to John to wrap this up. Let's talk a little bit about quality issues here. Hopefully your citrus does not look like those oranges there on the left-hand picture. You know, quality translates into marketability. I mean, that's really what I think about when someone talks about the quality of the product. We're looking and checking for physical defects, mold, pest damage. This may be done to government standards and or private standards. So often there will be some sort of a marketing order standard, a USDA grade or UNECE grade, for example, in the EU is commonly used. But there may be private standards as well in terms of defects. Clearly, the almond up there that's being devoured by a moth larvae is not what you want to see, but there can be standards for a variety of things like chip and scratch in almonds, a closed shell in pistachios. Other things that you might test for in terms of quality would be things like rancidity, off odors or tastes, especially with high-fat products, they can go stale if they're shipped in adverse conditions. So looking at the fatty acid or peroxide tests in nuts, volatiles like hexanol, they're increasingly looking at different types of chemical markers that they can try to tie to the rancidity phenomenon. And of course, the organoleptic or sensory evaluations, the taste and smell tests, that are the ultimate decision as far as whether or not the consumer would accept that product. Other things to consider yourself in this process is the pest control measures. Chemical fumigation is often done on conventional products to prevent outgrowth of insects or pests during the shipping or transport process. If you have an organic commodity, you might do some sort of a controlled atmosphere CO2 heat regime or freezing to kill the insects. And I think the other thing to think about is the shipping conditions themselves. If you do a lot of work in testing and sorting to get your product in its highest quality state before it ships, there's this whole period where you no longer have to the end consumer. So you need to think about things like verifying shipping conditions. I have a little data logger there in that one picture called a hobo. And there's a number of these types of products available where you can actually put this in a container with your load and verify at the other end what the temperature and relative humidity conditions were that load faced. Also, you can look at things like having a retained sample system. Again, this is what you always want to do if possible, is have retained samples kept under ideal conditions. For most commodities or most food products, we know what those optimal conditions are for storage. If you've done any kind of shelf life studies, you know what those are. A lot of the stored commodities that we deal with, dried fruits and tree nuts, we know that you want to keep it at about 60% relative humidity and some sort of a refrigerated temperature. That's going to maximize your long-term storage of that product and the freshness of that product. And these are serious considerations, this whole idea of what happens during shipment. Before we open this up to discussion here, I mean, I have this data that I got from a colleague in the industry. They were looking at shipping container data, and these are separate containers on a shipment that they looked at, monitoring with one of those data loggers the temperature and the humidity. And the sort of up and down EKG pattern, both at the beginning and the end of these graphs, shows the wide swings in temperature and relative humidity that could occur during storage in the port before shipment, and subsequently when it got to the port where it was being received and offloaded for the customer. In the middle, you see a relatively smooth graph, and that's when the container was on the water. I think these were not refrigerated containers, so you saw quite a bit of change in temperature and humidity. So sometimes when you see a product get overseas and it has a different quality profile than what you see back home in your retained sample or when you shipped it, this could be part of what's going on. So I think at this point, we kind of opened this up for some questions, right? I think, John, you were going to ask a few questions of Wiley and I.
Well, you were getting to 11 o'clock, so let's first see if there are any more questions from the audience, and then maybe if anyone has, kind of a final thought to give, we might slip that in before we, let everybody get back to their day.
John, did you have a few comments on GFSI you wanted to share too, or?
Yeah, no, I think we're good on that. I think we just want to go ahead and see if anybody has any questions that they have. I believe, can you guys see the virtual training schedule
Yes.
that I put up there?
Yes.
Good. So I wanted to share that with everybody too, including the one that we have, another free one on October 7th on sampling for success that you guys have planned.
Yeah. That's you and me, right, Tom?
Yes, that's right.
Yeah, and there's more on our website as well. We have a bunch, including one tomorrow on what we've learned about, food manufacturing in the COVID era, kind of lessons for the food industry too. So, but definitely want to open this up to questions if anybody has them. All right, so
we've had Tom's final thoughts. John's final thoughts. Tom, anything you want to kind of give people as a takeaway before we sign off?
I think you just need to know what you're up against. Know what those MRLs overseas are. Be prepared for asking the right questions when you ship products. Make sure that the container is going to be in good condition and that it's going to be in the proper place of the ship, so you don't have these adverse impacts of the shipping temperatures and humidities. Just prepare. Just be prepared. Yeah. Or if you're importing, know what those FDA detention lists look like and see if your product's going to be tied up in them.
And I guess I'll just say that, we had a lot that we wanted to go through today. So, there's, a world of detail in any, really any slide that you've seen today. So if you have any, further questions or, other things that we can help you out with, please, feel free to reach out to any of us. I had my information posted earlier. You can, find or, contact the administrators, for our, cell phones or email addresses, and just let us know if there are any questions.
Great.
And I guess with that,
questions, guys.
Pesticides used in grapes and raisins, typically water soluble. It really depends on the pesticide. To maybe make an overgeneralization, I think you find that a lot of the older chemistries, think like DDT, are kind of on the low water solubility end, which is where we get some of that environmental persistence that's become a problem. Whereas you have some newer pesticides, glyphosate comes immediately to mind, that are very water soluble. So so while there is this kind of shift towards compounds that are more water soluble that might not last so long in the environment, although then you have leaching and groundwater issues potentially. I don't know if I could say that for any given commodity that there's a real this one has water soluble or non-water soluble. It really just you have a kind of wide range, but somewhat of a trend towards more water solubility.
And that's one of your challenges in analysis, right? The different chemical characteristics of the pesticides means that there's no one magic bullet screen.
Yeah, not just water solubility, but volatility as well.
Right.
You have some that are closer to gases, as you get into, the fumigants, which tend to be gases, and that, sometimes requires a separate analysis to be able to capture things that are very volatile.
Great. Well, thanks everyone for attending. It was good to have you. And like Wiley was saying, reach out if you have questions in the future or anything we can help with. We definitely want to be here as a resource to meet you guys' needs.
Absolutely.
Have a good rest of the day, everybody.
Thank you, everyone.